Now looking at the intrinsic pathway, we can see that we get more and more returns resulting in a large amount of fibrin. And as time goes on, it looks like more and more fibrin will be produced. So how is it that our clots don't grow too big? Well, it turns out that thrombin produces a sixth protein, a very important one, called antithrombin. And antithrombin, as the name might suggest, leads to the inhibition of the activity of thrombin and factor 10, which leads to the production of thrombin. So as a negative feedback loop, it stops the production of thrombin by inhibiting factor 10, and it stops the activity of thrombin by inhibiting thrombin itself, meaning that all of these factors 5, 7, 8, 10, 11, and 13 can no longer be produced. And eventually, the pathway shuts down after the clot has grown sufficiently large. This is our body's way of maintaining hemostasis and making sure clots don't grow too big and break off. Because if they do, then smaller pieces of that clot called embolus, or emboli, will eventually fall into smaller blood vessels somewhere else in the body and form an infarction. If they form in the brain, they cause a stroke. If they form in the heart, they cause a heart attack. If they form in the lungs, it's a pulmonary infarction. As such, this is why antithrombin deficiency is one of the leading genetic causes of thrombophilia.